Have you ever sat down and thought, what if AI could actually think like us?
Hmm.
I mean, not just processing information, but reasoning through problems,
Yeah.
strategizing, even having those aha moments we usually think of as human intuition.
Yeah.
Well, guess what? There's this new family of AI models called DeepSeek, and they're making that a reality.
Oh.
We're going to be breaking down a research paper that literally just came out.
Okay.
It details how these models work and what they can do. It's pretty amazing stuff.
Yeah, I've been reading up on DeepSeek. It's fascinating how they're pushing the boundaries of what we thought AI could do.
Totally. It's not just pattern recognition anymore.
Right.
It's like they're learning to reason their way through complex problems step by step.
Exactly.
Okay, so the paper focuses on two main models.
Yeah.
DeepSeek-R1-Zero and DeepSeek-R1.
Okay.
They're both about reasoning, but they get there in different ways.
Gotcha.
So DeepSeek-R1-Zero is trained purely through reinforcement learning.
Interesting.
No hand-holding, no pre-labeled data.
So it's like being thrown in the deep end with no floaties.
Exactly.
Sink or swim.
Right. And what's crazy is that DeepSeek-R1-Zero figured out how to swim.
Really?
The researchers tested it on some tough math problems from the AIME 2024 exam.
Okay.
At first, it only solved about 15.6% of them. But after training, its accuracy jumped to 71%.
Wow, that's a huge improvement.
It's a massive jump.
Yeah, that's like going from barely passing to acing the test.
Totally. And here's where it gets even cooler.
Okay.
They observed that DeepSeek-R1-Zero actually learned to spend more time thinking about a problem before trying to solve it.
Like it was taking its time to understand the problem?
Yeah, it wasn't programmed to do this. It evolved this strategy on its own through the whole reinforcement learning process.
That's really interesting. It's like it developed a strategy for problem solving.
Yeah, it's not just about getting the right answer anymore.
Right.
It's about understanding how to get there.
It's almost like they're developing their own thought processes.
It really is.
Yeah.
And it gets even weirder when you look at specific examples in the paper.
Oh.
There's this one where the AI is working through a complex math problem, and it literally pauses mid-calculation.
Wait, really?
Yeah.
Like it stops and says, hold on a second. Let me think about this.
Well, not in those exact words.
Right.
But basically, yeah.
Wow. So it reevaluates its approach and decides to try a different strategy.
Exactly.
That's amazing. It's like witnessing an aha moment in real time.
It really is.
As if the AI suddenly realized its initial approach wasn't working.
It's like getting a glimpse into the thought process of a machine.
And that process is starting to look a lot like our own.
A little too much like our own, maybe.
Well, perhaps.
But DeepSeek-R1-Zero wasn't perfect, of course. It would get the right answers. But its solutions were often messy.
Really?
And difficult for us humans to understand.
Oh, so it was like a brilliant but eccentric professor who couldn't quite explain their ideas in a way that made sense to anyone else.
That's a perfect analogy. So that's where DeepSeek-R1 comes in.
Okay.
It takes that raw reasoning power of DeepSeek-R1-Zero.
Right.
And adds a layer of refinement.
So they smoothed out the rough edges.
Exactly. DeepSeek-R1 combines reinforcement learning with a little bit of initial human guidance.
Interesting. What they call cold start data.
Right.
Right.
The goal was to develop an AI that's not just powerful, but also user-friendly.
Makes sense.
To do this, they used a 4-stage training process.
Okay, so walk us through these stages.
Sure.
How did they take this raw talent and turn it into a well-rounded student?
Okay, so in the first stage,
Yeah.
they took a pre-existing model called DeepSeek V3 base
Okay.
and fine-tuned it on a very carefully curated data set.
Interesting.
This data set was all about showcasing clear, human-readable reasoning.
So it's like giving the AI good examples to learn from, like a teacher demonstrating a problem-solving technique on the blackboard.
That's a great way to put it.
Ooh.
They gave it a head start in learning how to think clearly and logically. Then they applied the same reinforcement learning techniques they used with DeepSeek-R1-Zero, but this time with a model that already had some good reasoning habits.
So they combined the power of self-discovery with some structured learning.
Exactly.
What happened in the next stages. So in stage 3, they took the model, which by this point was, pretty good at reasoning, and they had it generate even more data.
Okay.
But this time they expanded beyond just reasoning tasks.
Interesting. So what other stuff did they include?
Well, they added things like writing, factual question answering, even self-awareness.
Wow, so they were really trying to round out its education.
Yeah. That's a great way to put it. And then that final stage, that was all about reinforcement learning again.
Okay.
But with a focus on helpfulness and harmlessness.
Gotcha. So they wanted to make sure it was giving good answers.
Right. And that it was avoiding any, potentially harmful or biased content.
It sounds like they really wanted to make sure DeepSeek-R1 was not just smart, but also responsible.
Yeah, absolutely. They knew how important it was to build AI that aligns with human values.
Totally.
Yeah.
Now, I'm curious, how did DeepSeek-R1 stack up against other AI models out there?
Great question.
Did all that training actually pay off?
It definitely did. DeepSeek-R1 went head-to-head with some of the leading AI models, including OpenAI's O1-1217, and the results were impressive.
Really? So how did it do?
It performed well across a wide range of tasks.
Like what kind of tasks?
We're talking math coding, general knowledge, even creative writing.
Wow, so it's like a multi-talented AI.
Uh-huh. Exactly.
But I'm guessing there are still some areas where it needs to improve.
Of course, no AI is perfect. Like DeepSeek-R1 is great at a lot of things. But it still has trouble with tasks that require multiple turns of conversation. Or very specific output formats like JSON.
Yeah, that makes sense.
Yeah.
I guess it shows that AI still has room to grow.
Definitely. It's a constantly evolving field.
For sure. Okay, so let's switch gears a bit and talk about this idea of making DeepSeek-R1 more accessible.
Right.
By distilling its power into smaller models. This idea of like democratizing advanced AI is really fascinating to me.
Yeah, it's huge. The researchers managed to create smaller versions of DeepSeek-R1. And what's amazing is that these smaller models, like DeepSeek-R1-7B, they still beat out larger non-reasoning models like GPT-4o on a bunch of different tasks.
That's wild. So it's not just about the size of the models, it's about the reasoning skills that are built into it.
Exactly. And being able to put those skills into smaller models has huge implications.
In what way?
Well, imagine running these powerful AI models on everyday devices.
Yeah.
Not just massive supercomputers.
Right.
It could totally change how we use AI in a ton of different fields.
That's super exciting. Now, you mentioned earlier that there's some debate about how to create these smaller reasoning models.
Oh, yeah.
Could you expand on that a bit?
Sure. So some people think it's better to distill smaller models from bigger ones. And others think it's better to train them directly using reinforcement learning.
Okay. So it's like two different schools of thought.
Right. Both approaches have pros and cons.
Sounds like there's no clear winner yet.
Not really. It's an active area of research.
Right.
And the best approach might depend on, the specific task or the resources you have.
That makes sense. So it's all about finding the right tool for the job.
Exactly.
Okay, so I noticed the researchers mentioned some failed attempts in their paper.
Oh, yeah.
Which I always find interesting because, sometimes failures can be just as informative as successes.
Absolutely. It's important to learn from both.
Totally. So what were some of the things they tried that didn't work?
Well, one thing they tried was using what's called process reward models.
I don't think I've heard of that. What is that?
So the idea is to give feedback on the reasoning process itself.
Oh, okay. So not just rewarding the AI for getting the right answer.
Right, but for thinking in a particular way.
Interesting. But it didn't work.
Not really. It turns out it's really hard to define a clear reward system for reasoning.
Why is that?
Well, what might seem like a logical step to one person could be totally wrong to someone else.
Oh, I see. So it's subjective.
Very much so. It's like trying to judge someone's thoughts.
Right. You can't really quantify that.
Exactly. Another thing they tried was Monte Carlo tree search.
Okay. Isn't that used in games like chess and Go?
Yeah, it's been very successful in those areas.
So they were trying to apply it to language generation.
Exactly. And while it showed some promise, they had a hard time adapting it to the complexities of language.
Interesting. So even techniques that work well in one area don't always transfer to other areas.
Exactly. And I think that's a good reminder that AI research is all about experimentation.
Absolutely. It's about trying new things and seeing what works.
And learning from what doesn't.
Well, I think we've covered a lot of ground in this deep dive.
We have.
We talked about the amazing things DeepSeek-R1 can do, the challenges of creating smaller, more accessible reasoning models.
Right.
And the importance of learning from our mistakes.
I think it's been a really productive discussion.
I agree with you. I don't know about you.
Yeah.
But I'm feeling kind of a mix of awe and apprehension about the future of AI.
Yeah, I get that.
Yeah.
It's clear that we're entering a new era of technological advancement.
For sure.
And it's exciting, but also a little bit scary.
Totally. Now, before we wrap up this part of our deep dive,
Okay.
I want to go back to something we talked about earlier.
Okay.
Those aha moments that the researchers observed in DeepSeek-R1-Zero.
Oh, yeah.
It's like the AI was experiencing a sudden flash of insight, just like a human would.
Those moments are truly fascinating. They give us a peek into the potential for AI.
Yeah.
To not just copy human intelligence, but to maybe even surpass it in some ways.
That's a really thought-provoking idea.
Yeah.
It makes you wonder what other human-like skills AI might develop in the future.
It does. It raises some really big questions about what it means to be human.
And what our relationship with technology will be like in the future.
Definitely. These are questions that we'll keep exploring in the last part of our deep dive.
Okay, so to everyone listening, stay tuned for more. Okay, so we've gone pretty deep into DeepSeek.
Yeah, we have.
I thought maybe we could recap some of the key takeaways before we finish up.
That's a good idea. I think it helps to, pull everything together.
Absolutely. So let's start with DeepSeek-R1-Zero.
Okay.
It learned entirely through reinforcement learning, right?
Right, which means no pre-labeled data, no instructions. It had to learn on its own.
And it did a pretty amazing job. Remember its accuracy on those AIME math problems?
Oh, yeah. It went from 15.6% to 71%.
Huge improvement. That really shows the power of reinforcement learning.
Definitely. It shows how these models can learn and adapt.
But it wasn't just about getting the right answers. DeepSeek-R1-Zero also started doing things that looked a lot like human problem solving.
Like what?
Well, remember how it would pause and reevaluate its approach?
Oh, yeah. It was like it hit a wall and had to think about how to get around it.
Exactly. Almost like those aha moments we get.
Those were really cool. They weren't programmed in or anything.
Right. They just emerged naturally.
Which suggests that these AI systems are developing their own internal reasoning processes.
And those processes are becoming more and more complex.
It's pretty mind-blowing when you think about it.
It is a little bit scary, too.
I get that.
Yeah.
But I think it's important to be curious about it,
Yeah, I agree. We need to approach this with a sense of caution, but also optimism.
Exactly. AI has the potential to really change things for the better.
Okay, so let's move on to DeepSeek-R1. It builds on DeepSeek-R1-Zero. But it also has some initial human guidance.
Right. And that multi-stage training process they used really helped to refine it.
Absolutely.